Okay, this is Project Test 7, video number 2, problems 11 to 20. A sociologist collected data from a sample of people on their highest level of education and the number of times they visited any fast food restaurant during the previous week. The data are summarized in the box plots. Based on the box plots, which of the following statements must be true? The number of people surveyed at the more than 4-year school, so the number at the 4-year school, 4-year college level is greater than the number of people surveyed at the high school. Unfortunately, we don't know anything about the numbers here or here. So there could be more at the 4-year college or there could be less. We just don't know anything about the actual numbers. The proportion of people surveyed from the first quartile to the third quartile, in other words, 50% at the 4-year college, is less than the respective proportion at the community college. And the answer is no, because the proportions are going to be the same. It's still going to be Q3 minus Q1, which is 50%. All right, so it doesn't matter what the size of the population is, it's going to be 50%. So that one is false. The interquartile range for the number of visits for the more than 4-year, so we're looking at the more than 4-year, and the IQR here is Q3 minus Q1 equals 2 minus 1, which is 1, is less than the IQR for the number of visits at the community college. And at the community college, we have approximately 2.5 to 1. So 2.5 minus 1 is 1.5. So yes, the more than 4-year college is less than what we had at the community college. That's true. The answer to number 11 is C. For number 12, for recent season in college football, the total number of rushing yards for that season is recorded for each running back. The mean number of rushing yards for the running backs in the season was 790. One running back had 1,637 for the season, which is 2.42 standard deviations above the mean. This is a z-score. Now, I have no idea whether it's normal or not, so I can't do anything with normality, but we can apply a z-score to any distribution. So what is the standard deviation of the number of rushing yards for the running backs that's the season? Well, regardless whether or not we can use the empirical rule, this is always true. So that's always true. So we know Z is 2.42. We know we're looking for the standard deviation of the population. We know the mean rushing yards are 790, and we know this guy ran for 1,637. All right. 1,637 minus 790 equals 847. So 2.42 equals 847 over this, over the standard deviation. When I solve, basically I'm solving a proportion. I'm multiplying these two and dividing by that. So 847 divided by 2.42 equals the standard deviation equal to 350. So 350 yards. And so our answer to number 12 is C. For number 13, first-year students enrolled at a college were asked whether they played video games. The response is classified by whether the students were enrolled in the School of Sciences or the School of Arts, as shown in the table. Of the students enrolled at the School of Arts who responded, approximately what proportion play video games? So of, that's a denominator word. So of the arts, so we're going to put arts in the denominator. So arts is going to go in the denominator. And we have 793 from the School of Arts. What proportion play video games? And please remember, it's the intersection that goes in the numerator. So my intersection is 347. And if we take 347 and we divide it by 793, we end up getting 0.4375. Closest answer is C. So for number 13, we end up with C. Moving right along to number 14. A pharmaceutical company manufactures medicine to reduce pain caused by migraine headaches. The company is investigating whether new medicine is more effective in reducing pain than the current medicine. A random sample of 500 participants who experienced migraines was selected, and the participants were randomly assigned to one of two groups. So we're placing them in two groups of equal size. The first group received the current medicine, and the second group received the new medicine. So we have basically, we start off with a random assignment. And we get a current, and we have the new. When a participant experienced a migraine, he or she was instructed to take the medicine, and 15 minutes after taking the medicine, to rate the pain relief on a scale of 1 to 10, with 1 being no relief to 10 being complete relief. At the end of 6 months, the average pain relief was calculated. So basically, calculate pain relief or compare pain relief. Which of the following is the best description of the study? All right, we did no blocking. We just placed them into groups. So first of all, and we made assignment. The fact that we had assignment tells me it's not an observational study, it's an experiment. No one was tested twice. There was no matching of pairs. This is a completely randomized design. Okay. Number 15, a marketing firm obtained samples of 20 people in 5 regions of the country to investigate the level of interest in a new product. People in the sample were asked to rate their level of interest on a scale of 1 to 10, with 1 being the least amount of interest and 10 being the greatest. The histograms show the results for each region. The graph for which region displays data for level of interest with the least standard deviation. So we want the smallest standard deviation. Well, if you remember, our standard deviation formula is the summation of x minus mu squared over n. Well, they all had sample sizes of 20, so that's not going to change. So what matters is this distance. Whatever the average is, we want the minimum distance. Well, I'm not sure, but I'm guessing my average right here is going to be right about there. This average is here. This average is here. This average is here. And the one that has the data that's closest to the average is D. And since the data is closest to the average, the one with the closest to the average will have the smallest numerator, which means it will have the smallest standard deviation. So because the D is less spread out than the others, it will have the smaller standard deviation. Remember, standard deviation is a measure of spread, so the less spread out the data is, the smaller the standard deviation. Okay, moving on to number 16. The transportation department of a large city wants to estimate the proportion of residents who would use a system of aerial gondolas to commute to work. The gondolas would be part of the city's effort to relieve traffic congestion. The department asked a random sample of residents whether they would use the gondolas. So they're taking a random sample, that's probably important. The residents could respond with saying yes, no, or maybe. Which of the following is the best description for the data used by the department? The first thing is the census, and they took a random sample, so they didn't sample the entire city. If they sampled the entire city, it would be. No treatments were assigned, so this is not an experiment. So basically, 16 is B. We just took a random sample. A sample survey. Okay? We surveyed people doing what they were already interested in doing. No treatments were assigned. Number 17. This one is evil. They're totally out to get you on this. This shows the College Board wants to be tricky. To obtain certification for a certain occupation, candidates take a proficiency exam. The exam consists of 2 sections, and neither section should be more difficult than the other. So basically, they're saying section 1 should equal section 2 in difficulty level. To investigate whether one section of the exam was more difficult than the other, a random sample of 50 candidates was selected. The candidate took the exam, and their scores on each section were recorded. So basically, each candidate had both treatments. This tells me that I should be looking for a mu D equal to 0, and the alternative, mu D not equal to 0, because they were tested twice. They had the first section and the second section, and they're telling us they want no difference. All right, so which of the following is a test statistic for the appropriate test to determine if there is a significant mean difference between the percent correct on the 2 sections, first minus second? And by the way, mean differences should be another hint to doing this. So basically, if I were writing down my formula, I would go x bar D minus mu D over SD divided by square root of n. So mu D is 0. This is 10. Standard deviation is 8. And I'm taking the square root of my sample size, and we had a square root of 50. So this is what I should be looking for. And I immediately start looking through these answers, and I don't see exactly that. Okay, this is where they really are tricking, and you have to be confident that you know what you're talking about. So I'm confident in that. And I know it's not a chi-squared. I know it's not a proportion, but it's possible that I misread the question, and maybe that's supposed to be my answer. However, let's go back. If we really believe that we're doing right, and we really believe that this would be a paired test, let's consider this. If I take away this part, because minus 0 doesn't matter. What's 75 minus 65? 10. So this is my answer. So technically, they just said, hey, you know what? Let's mess them up. I don't like it, but that's what they did there. All right. So 17 is it is not a paired test. This would have been wrong. All right. That would have been wrong. Excuse me. It is a paired test. It is not a 2-sample test. This was a single sample. This was a 2-sample. So basically, what may have helped you, if you consider that it's like, hey, we took a single sample. We had one sample of 50 candidates, and we compared their first and second scores. If it were a 2-sample, you go, okay, we had one group take the first and one group take the second. This is obviously not a 2-sample, but they kind of disguised the way that it was a paired. I don't like that they did that. New employees, this is number 18, at a large corporation, go through a training program during the first week of employment. The new employee takes a written assessment at the completion of the program to determine how prepared they are for their jobs. A score greater than the mean indicates a well-prepared employee. Assume the following distributions of new employee scores have the same mean score, the same maximum score, and the same minimum score. Which distribution has a shape that is more likely to represent the percent of well-prepared employees? Well, let's consider this. Here's my min value. Here's my max value. And let's just put our mean almost in the middle. As close to the middle as I can get it. I guess I should sit down a little bit. Well, if I have more values up here, I have more prepared people. So I want as few as possible down here. So I want this small and I want this with a lot. So what's that shape? Oh, because I have a lot up here and few down here, I need the distribution of scores is skewed, stretched to the left. And that makes sense because if I have this, my median's up here. So over half of my employees, I know that more than 50%, my median's above my mean. So more than half of my employees are well qualified. So it's skewed to the left, 18 is B. Moving on to 19. Based on his past record, Luke, an archer for a college archery team, has a probability of 0.9 of hitting the inner ring of the target with a shot of the arrow. Assume that in one practice, Luke will attempt 5 shots and that each shot is independent from the others. Let the random variable X represent the number of times he hits the inner ring on the target in 5 attempts. What's the probability that the number of times Luke hits the inner ring out of the 5 attempts is less than the mean of X? Well, let's calculate the mean of X because that's easy enough. The expected value of X is in P. Well, we know we're shooting 5 times, and the probability they gave us was 0.9. And 5 times 0.9 is 4.5. So what's the probability that it's less than the mean of X? So less than 4.5. Well, basically, I can either hit the target 0 times, 1 time, 2 times, 3, 4, or 5. So I'm interested in these values right here. And there's actually several different ways to go. I can add up 0 plus, I can add up all these probabilities, and that will get me to the correct answer. I can do 1 minus the probability that I hit it all 5 times. So 1 minus 0.59049, and that'll work. Or I can recognize this as a binomial, which it is. And basically, in that case, it's a binomial CDF, and I want the probability of 0 plus 1, 2, 3, 4, 5. So in this case, and I want to show this just as a reminder, it's 5, choose 0. Not that this is the fastest way, because it's not for this problem. 0.9 to the 0, 0.1 to the 5th, plus dot, 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 plus 5, choose 4, 0.9 to the 4th, and then 0.1, 5 minus 4 is 1. So 1 minus the binom CDF, trials is 5, probabilities 0.9, and the highest value we didn't want is 4. Oh, excuse me, this is not a 1 minus. This is just a binom CDF. Binom CDF 5, etc. And if I did that, the reason it's not a 1 minus is because it's not at least. So second vars, binomial CDF, trials is 5, P is 0.9, X value is 4. And I get 0.40951. So A, well, look at this. What if I did 1 minus the 1 it can't be? 1 minus 0.59049 is 0.40951. Or if I added up all of these individual values. But the key here was to know how to calculate the expected value. 5 times 0.9 is 4.5. So anything less than 4.5, we needed to add up. Everything else we ignore. Okay, so that's number 19. On to number 20. Number 20, a medical center conducted a study to investigate cholesterol levels in people who have had heart attacks. A random sample of 16 people was obtained from the names of all patients of the medical center who had a heart attack in the previous year. So we have an N equals 16. Of the people in the sample, the mean cholesterol level was 264.7. So our X bar equals 264.7. And the standard deviation of the sample is 42.12. Assuming all conditions for inference were met, which of the following is a 90% confidence interval for the mean cholesterol level? So if I were doing this, on a FRQ, I'd be writing X bar plus or minus T star S divided by square root of N. So 264.7 plus or minus, we'll come back to the T star in just a moment, 42.12 over the square root of 16. So let's go ahead and calculate our T star. Second vars, inverse T, area. And we're supposed to be calculating a 90% confidence interval. So parenthesis 1 minus 0.90, close parenthesis divided by 2. Degrees of freedom, 16 minus 1, or 15. And we'd get 1.753. But since this is a multiple choice test, we can do this much, much faster. And we wouldn't have to show that work. So here we go, multiple choice test. Stat, test, T interval, which is number 8. And it's a T interval because we're using the standard deviation of the sample. X bar is 264.7. Our sample standard deviation of 42.12. Sample size is 16. Confidence level 0.90. Calculate. And we get 246.24 to 283.16. So our answer is C. All right. And obviously this would be the work that you would show for a FRQ, but for a multiple choice test, organize your data, punch it in as fast as you can and move on. All right, that concludes this video.